Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video, another video in our series dealing with functions, and another example looking at injective functions, is going to, it's going to concentrate on another example of injective functions. Okay, so first of all, what I'm going to just do is provide a definition of an injective function. So once again, our definitions, and we're going to define this in two ways. Well, first of all, if I want to check to see whether a function is injective or not, I need to have that function, and that function needs to be defined on a domain and also on a codomain. So I need to do that. So let's say let A and B be non-empty sets. Okay, so let A and B be non-empty sets, and let F be a mapping from A into B, if that makes sense. Okay, well then we say that F is injective. Okay, we say that F is injective or one-to-one if for all x1 and x2s that are in our domain. Okay, if for them all, okay, we have the following. Okay, we have the following. Okay, the following. Okay, and it is this: if x1, okay, if x1 is not equal to x2, well then this implies that f of x1 is not equal to f of x2. Okay, that's what we mean to be injective. Okay. What I'm basically saying is that if you have two separate values, okay, if they are two separate values, and that if you map them across, what we need to end up with is two separate values. That's one way to think about it. An alternative way to think about it is like this. Okay, it's okay. So in this case here, we have two separate values in the domain. And if we apply the function f to them two separate values, they need to go to two separate destinations. The two destinations need to be separate. Okay. An alternative way is if we have two values, okay, if we have two values in the codomain or in the range, okay, if we have two values in the range that are equal, well then this implies okay, that they came from the same location, that x1 is equal to x2. Okay, so this is an alternative definition. So there's two ways to look at this. Okay, we can look at it like this. Okay, in one way, that's injective, and then we can look at it in this particular way. This is what also is our definition of injectivity. They're just going from two different directions, if that makes sense. So let's consider a function. So let's consider, okay, the function. Okay, let's say the function is f, and what f is going to do is it's going to map the integers. It's going to map the integers into the rational numbers. Okay, and it's defined by the function f of x is equal to, let's say it's equal to 4x minus 2 divided by 3. Okay, so what it says is this, is that it's going to take any integer. Okay, and you know that an integer, 4 times any integer is an integer. When you take 2 away from it, you're still going to have an integer. But what we have on the top here, the numerator, is we have an integer divided by 3, which by definition is going to be a rational number. Okay, it's a fraction that we have here. Okay, now the range of values is not necessarily going to be the same as the codomain. Okay, so let's just keep that in mind. Okay, so what we want to try to do is this: is let's consider the function defined by this here, and the question is f injective? Okay, is f injective? Okay, question mark. So what we do is we just take this particular way of doing things here. Okay, so let's just take this particular way. We'll start here and see do we get here. Okay, so let's just say let x1 and x2 be elements of Z. They're elements of our domain. Okay, and let's say let f of x1 equal f of x2. Okay, so that's what we're going to do here. We're going to let the both values from the domain, okay, be mapped into the same value. Okay, well, what does this imply? Well, this implies that 4 times x1 minus 2 all over 3 must be equal to 4 times x2 minus 2 all over 3. What does this imply? This implies that 4x1 minus 2 must be equal to 4x2 minus 2. What does this imply? Well, this implies that 4x1 must be equal to 4x2, which implies that x1 is equal to x2. Okay? So this is important for us. So once again, what we've shown here is this, is that here's our function, okay? Here's the function that we're interested in testing, okay? We've given its mapping based off its domain and its codomain, okay, based off those particular sets, and we've given its prototype or its actual implementation, how it works. And based off this fact, what we did was we just chose two values from our domain, okay? We assumed that those two values were mapped to the same place, and then what we looked at was we looked at the consequence of this particular assumption here, and the consequence of this assumption is that the two values that were originally chosen must have been the same two values, okay? So this is what we've ended up with here. We've assumed this to be the case, okay? That's what it says. If f of x1 is equal to f of x2, well, what we've had then is the then bit is down here. So this is the then, okay? Then what we've arrived at is x1 is equal to x2. So actually what we've actually shown here is clearly, so hence f is an injective function, okay? So there you go, guys. So that was our quick test to see whether a function was injective. Okay. In the next example, we'll have a look at something a little bit more complicated and try to test for injectivity. So once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way helpful. And thank you for watching. Okay, bye bye.